basically the climate crisis. And today we're working with one of our good partners, the 2030 District in Haym, who helped bring this together to talk about energy and equity in buildings. And we're going to have a great panel tonight. And the series mission is basically to address a lot of the issues and questions that people have about energy in a New York context, but I think some of this stuff can be talked about in a broader sense as well. So it's not, while we're all talking from a New York context, we, like, a lot of this information can apply to context in other cities and other buildings. So I'm really glad you can join us today. And I will pass it off to Haym at the New York City 2030 District to talk a little bit about the 2030 District and the work that he's doing. And I will stop sharing.
Hello, thank you, Mike, and thanks to the New School and the Tishman Center. And thank you all for joining us. We're hopeful that this will be the beginning of a series that will both inform and activate people in the New School community and the New York City community and the climate community beyond. Tonight's subject is building energy, and we hope to do other events which will focus on other subjects that are essential to meeting the climate crisis in the city. Things like renewable energy and distributed energy and best practices and community activities. I'd like to just tell you a few things about the 2030 District. And if you could just put my slides up, I'll run through that very quickly, and then we'll introduce our speakers. Here we go. Thank you. So the 2030 District is a private-public partnership of stakeholders. We are a volunteer group, a not-for-profit under the Fund for the City of New York. And we have established a district in downtown Manhattan and downtown Brooklyn, lower Manhattan and downtown Brooklyn. We currently have over 21 million square feet of property pledged to the district's goals, as I'll describe. And here are some of them listed. You know, the Brooklyn Navy Yard and the New School, Pratt and others. We intend to have a citywide impact, but we also are working within this dedicated district. Next slide. The year 2030 is the year that the scientists say we are toast if we do not limit or level off greenhouse gas emissions globally. You can see this chart, which is still pretty accurate. The 2 degrees Celsius ceiling is a kind of a break point, and the year 2030 is a critical year to bend that curve to level off global greenhouse gas emissions. If we don't, some of these other lines, as you can see, these RCPs or representative concentration paths of climate in the atmosphere are going to lead to much higher than 2 degrees Celsius average global temperatures in the years to come. Next slide. So the 2030 Challenge for Planning, which has been adopted by many national organizations and industry groups and others in the building sector, targets a 50% reduction in greenhouse gas emissions from a 2013 baseline by the year 2030, and we target for new buildings and major alterations a carbon neutral or a net zero target. That's very aggressive, and that's what we're shooting for at a district scale. Next slide. We are a partnership of 3 partner types: property owners and managers, service and professionals, community, civic, and educational organizations. New School is both a property and a community partner, and we have 5 goals: innovation, resilience, equity, policy advocacy, and financing these goals. I think the equity goal, which is something we identified years ago, is more and more relevant and one of the real subjects of our meeting and our series this evening. Thank you. Next one. So we are implementing a program in Brooklyn called EcoSmart Brooklyn. What we do is try to connect the dots in the community and across the country. The 23rd district in New York City is one of a network of 20 districts across North America. In 20 cities, has over 500 million square feet of property pledged. Every district is different, like every city is different. The EcoSmart Brooklyn campaign is sponsored by the Brooklyn Borough President, is funded by NYSERDA. We are working to implement green retrofits, converting from fossil fuel heating to clean electric heating and cooling, using heat pumps and energy efficiency envelope improvements in all buildings in Brooklyn. We've done over 50 one to 4 family homes. We're working with multifamily properties and commercial properties. And you can reach us at heybrooklyn.org. Fill out a form. Let us know about your property. We can help you retrofit, working with NYSERDA and other programs. We're also working with Solar One and others to promote solar. And we hope you can visit us. You will hear a lot about heat pumps and a lot about building energy this evening. And we're doing this work on the ground in Brooklyn, and we hope to expand that, working with other community partners like New School, like Solar One, like 350 Brooklyn and others, and look forward to working with you on these events and others. Let me introduce our speakers this evening. And I hope you guys can get in touch with us. If you're interested in the 2030 district, you can reach us at info@nyc2030.org. We'll send out some information following the event. Maybe I'll put that up in the chat. Please get your questions together, because we will have questions, a long time for audience questions and answers at the end of the program. Let me introduce our speakers, I think in order. Actually, let me do it in reverse order, because I'm going to introduce Richard first. So Emily Baumbach is Senior Sustainability Consultant with Kinetic Communities Consulting, also known as KC3, and she also works with the New York City Accelerator to advise and guide properties to succeed in doing green retrofit projects. José Tulio Gálvez Contreras is a solar researcher and program manager with Here Comes Solar of Solar One. Solar One is a venerable and a truly fabulous not-for-profit advocate and facilitator of renewable energy projects in New York City. Richard Leigh is a visiting professor of physics at Pratt Institute. He's also the former research director for Urban Green Council, and truly an expert and a fearless advocate for sustainability. Also one of the real drivers of the policy that we'll discuss this evening to really electrify building heating and cooling, along with a whole host of other building improvements that he'll describe to you, to really help us get off fossil fuels in New York City. And he's got some detailed information to describe to you. So I'm going to turn it over to Richard now. Then we'll hear from, then I believe we're going to hear from Emily and then from Jose. Is that right? Is that the order that we agreed upon? I think so. So Richard, take it away.
Okay, thanks, Haym. I'm going to be sharing my screen, which will of course take me a second. No, I can do this. And take the 12 seconds to get going. Okay, you should see energy and equity, a big white screen up there. I hope that's working. Get that out of the way. And I will now move on and remind us all that we are in really big trouble. As a result of 200 years of industrial activity, we've got the most extraordinary climate change going on since the dinosaurs bit the dust from a direct hit. And we have a major institution, the Intergovernmental Panel on Climate Change, IPCC, which includes something like over 90% of the climate scientists on Earth. And they have been telling us with increasing intensity over the last 20 years that we are in trouble. And as of now, although Haym is absolutely correct, 2 degrees C is a serious problem. By the way, when we say 2 degrees C or 1.5, we're talking about the temperature increase above the pre-industrial temperatures, what the average temperatures were, say, in 1800 or 1850. And we are now 1.1 degrees C above those temperatures. So we're a good deal of the way up to 2 degrees C already. But after agreeing on that, people realized that even at 2 degrees C, there were going to be real problems. And so at the Paris Climate Conference in 2015, the representatives called on the IPCC to tell them, what do we have to do to stay under 1.5? And they reached an agreement that they would make every effort to stay under 1.5. And the result was the special report on doing it. And here is one page from that report. And what this page shows you is that the real answer is that we have to stop emitting greenhouse gases by 2050. And by stop, we say net zero, but really it means in a practical sense that we really have to stop the emitting. The little bits that we can pick up through inspired agriculture and that sort of thing are fairly minimal. However, the IPCC, in response to complaints from people who said that's not realistic, is to come up with some schemes where, yeah, okay, you can keep on burning fossil fuels and just come down more slowly with that. But then you're going to have to employ a whole lot of carbon capture and storage technology. I'm not going to spend any time on that in this meeting, other than to say that your government has spent over $1 billion on 11 climate capture and storage projects, and not one of them has succeeded, and not one of them is still operating. So to go this route and to continue to emit means that we are depending on technologies that we so far have been unable to make work. Every technology we need to reduce carbon emissions, we already have. So the way out is efficiency, and Emily and others, Jose will talk about that. Evolving the electric grid to be carbon free. We're not going to talk about that, but we know it's going to happen because NYSERDA and the state of New York are working on it here locally. And what I'm going to be talking about primarily is take all the ways where we directly use fossil fuels to make heat, to make hot water. I will not be doing transportation. That's a different meeting. And all of this, of course, is useful as the grid becomes greenhouse gas free. So in New York City, we have passed Local Law 97, and it is the law. It's not some policy that can come and go with the mayors, although they can have different levels of interest in implementing the policy. But what this law does is that this is a schematic representation of how many properties emit at different levels. And so the average is here in the middle, no numbers down here, but just so you get an idea. But what it's showing you that the impact of Local Law 97 is to come up with 2 fairly stringent limits. One comes into effect in 2024, and this is how many kilograms of greenhouse gases, CO2 plus methane plus nitrous oxides, you can emit per square foot of building And if you exceed that in 2024, you pay fines, and they are heavy fines. They are real. They've got the attention of the industry. And the ballpark estimate is that about 20% of properties are going to have to take some significant efforts to get their emissions down below that threshold. But something like 75 or 80% are probably okay, or can do it with fairly minor house cleaning operations. The 2030 limits, and these are built into the law, are much more stringent, and they're actually going to affect something like 75% of buildings, covering about that much area. I should mention these laws only apply to buildings that are 25,000 square feet or larger. There are about 30, an apartment is about 1,000 square feet on average, so think 25 apartments or more for residential, comparable for commercial. There are about 30,000 such buildings in the city. There are 1 million buildings in the city, so there are still over 900,000 buildings not covered by this, but they are all small and a different question. Right now, I'm looking just at Local Law 97. Of course, we have to get everyone to lower their usage. The state is going to play a role there also. Anyway, Local Law 97 will leave only about 25% of buildings untouched by 2030, and there are committees now at work to come up with the 2040 limits and maybe 2035 limits, which will be even more stringent. The only way that this can work is to stop burning fossil fuel in the buildings. So that brings me to the core of my presentation. And the first page here is about lighting. I'm going to cover it in about 2 seconds because lighting is all electric. So as the grid becomes carbon free, the lighting will no longer be responsible for greenhouse gases. So we should make it more efficient as possible, because that will be that many fewer wind turbines that we have to build to provide the electricity. So it's worth it at a cost level. But in terms of just pure greenhouse gas emissions, lighting is already pretty clean. It's as clean as the grid from which it draws power. Here are some nice steps people can take. I hope you read them and can move on to carry them out. They're all pretty straightforward items. I'd like to move forward to what to do with boilers used for heat and for hot water. And the first thing I have to warn you is that for many of you, the time this will matter is when your boiler breaks and you have to do something because the diapers are dirty. Well, you throw the diapers out, but the clothes are dirty. People need showers, hot water for the dishwasher, heat in the winter. What are you going to do? And the obvious thing that people have always done is to call a repair guy and replace your boiler. I'm telling you, don't just do it. Stop and think carefully, because by the time you're into 2030 and 2040, it will not be so easy to get gas, or it will be very expensive because of carbon taxes. And that is going to increase. And it's got to. If we does not increase, if we do not take these very unpleasant steps, then human civilization is just kind of doomed, at least at the level we're living in now. There'll be hordes, and by hordes, I mean millions of climate refugees coming across borders, and then collapse of existing economic relationships, all kinds of horrible things happening, which you can read about in reports from the IPCC, which are optimistic if we can keep the temperature certainly below 2 degrees, and we really hope down near 1.5 degrees. Then we can be a little optimistic. But the only way to do that is to stop burning gas. Best bet, put in a 100% electric system today. Second choice, don't replace, repair. Make that old thing last as long as you can, because then the electric alternatives will be getting less expensive, more readily available. People will know how to do it. The repair guy's going to argue, he wants to do the replacement, argue back. If you do a replacement, know that that unit is going to have to be ripped out in 10 to 15 years. So now I'm just going to talk about the electric systems and the air heat pumps. The thing about nature is heat is energy, just like the mechanical energy in that you use to push your bicycle along, or the electric power that's in a battery. But heat is a little bit funny because it has temperature characteristic, and it will only move from a place that is warm or hot to a place that is cooler. And what we want in the winter to keep our houses warm is the opposite. We want to take heat that is outdoors somewhere, bring it into the apartment, and have it help us keep the apartment warm or make the water hot. Now, there is a way to heat our apartments without doing that, and it's called the stupid way. It's resistance heat. And all the electric heat, or almost all the electric heat you find in the US today, is resistance heat, where you just put in so many, 1 kilowatt for every kilowatt hour of electricity you put in, you get 3,412 British thermal units of heat out. You just get out the energy you put in with electricity. Heat pumps are a far more effective way to do this. You put a bit of electricity into the heat pump, and it sucks heat from a cold place, like the cold air outdoors, effectively raises the temperature of that heat energy so that it can be dumped into the conditioned, warm conditioned space. And the heat that we get out into the conditioned space, which are called QH, Q hot, will be equal to what was brought in from the outside, plus what was added through electricity. This is a principle called the conservation of energy. You may have heard of it. It still works. However, the way that it works here is that by developing really good heat pumps, we can now put in a modest amount of electricity and get 3 to 4 times as much heat into the room. And what that means, compared to the resistance heat, is that we can lower the number of generating sources we need. The wind turbines, the solar cells, the hydroelectric dams, we can lower those by 60 to 75% because we're using a heat pump, and it requires that much less electricity. So there's really no argument about doing it. But tell me, Professor, can I go out and buy these today? Absolutely. There they are. This is an air-to-air source heat pump, so-called, because it circulates cold, it's wintertime, cold outside air through this outdoor box, and it makes that air colder because it has sucked heat out of it. But the cold air is ejected out into the air, and who cares about that? But it takes that heat and dumps it into this indoor unit that's in all the principal rooms, just like radiators are today, and they emit heat into the room and keep the interior cozy. This is called a ground source heat pump. And the only difference, the heat pump itself, the mechanism, the indoor units are all the same. The difference is that it pulls the heat out of water, and it makes that water cold. And then a pump pushes that cold water down underground, and the water is colder than 55 degrees. So heat flows from the ground into the water and warms it up. And then the warm water comes back up and goes back into the heat pump again and provides more heat, is cooled off again, and just cycles around. So the heat pump is pulling heat out of the ground. It can be pulling it out of pipes that are lowered into wells like this, or pipes that are simply buried 6 or 8 feet down in the lawn like this, depending on geology and all that. These are a bit more efficient because they're always getting the heat out of water that's at around 50, 55 degrees. Whereas the air source system has to work, even though the air coming into it on a cold winter night, excuse me, well, it will perhaps be at 5 degrees Fahrenheit or even 0. The heat pump will still work, but it works less efficiently, and it needs more electricity to keep the house warm. So the ground source system is better in that sense, a little more efficient, and it also does not put as big a spike onto the electrical system. The demand on the power system is lower on those peak nights. Remember, we have peak loads on the electric system today. They come on hot days in July. We're going to have peak loads on the electric system in the future, but those peak loads will come in the middle of the night in January when it's coldest. And that, as a matter of interest, Urban Green Council did a very interesting study on this, showing that for the next 10 years at least, New York City's electric system is ready to handle heat pumps, air source heat pumps, and some ground source, which is easier, but that after sometime in the early 2030s, Con Ed is going to have to start putting in a lot more wires to meet the demand of the heat pumps. Urban Green Council Grid Ready is the name of the study. So onward again, because I think I'm taking too much time. 2 other notes. The great thing about air source heat pumps, you can do it anywhere there is air. And since we breathe air, that's almost everywhere. So no problem. Ground source heat pumps run into 2 different kinds of challenges. One is that if you have underground infrastructure, which in New York City, we have underground infrastructure, copious amounts of it, it's a challenge. It can be done. St. Patrick's Cathedral runs on ground source heat pumps, but it is tricky and complicated, and sometimes geology is not with you either. So I have a friend who works upstate in installing both sorts of heat pumps, and he says he installs both of them depending on the situation. It's not just a slam dunk to put in the ground source, even though, as we'll see in a second, the economics of it are actually make this sort of a 50-50 choice today in New York State. Ground source heat pumps are a lot more expensive because you have to dig these holes. Air source you can just sort of install, but you get a 26% federal tax credit against your federal income tax, 26% of the capital cost of a ground source heat pump. That means that to you, as the owner, building owner, the cost of the ground source heat pump is 26% less than what you had to pay the contractor to put it in. And that that credit is not available for air source heat pumps. So my colleague upstate says that he puts them both in, and the cost difference between air source and ground source is actually pretty small, comparable to the difference from one job to another, which I think is very interesting. Now, there's a great set of bills that are now in the New York State legislature and might have even passed today. I've been sort of offline, but they are being passed by the legislature, and they will give ground source heat pumps another 25% credit, this time against New York State income tax. So if you pay New York State income tax, you'll be able to probably get a ground source system for less than you pay for an air source system if it's a practical thing to do. Equity note, you have to be paying a fair amount of taxes for this to be worth doing, but then these days to put in a heat pump, you need a fair amount of ready cash anyway. So what's it going to cost New York State to do this? Well, I grabbed, first of all, if we're talking about what it costs New York State, I don't consider the tax credits, because if somebody gets the tax credit for putting this in, that's good for them, but the rest of us are paying for it in our taxes. So if we're deciding what's going on for New York State as a whole, we forget all the tax credits and incentives. What's the total cost we'll have to pay, one way or another? And very ballpark numbers for a single family house, probably a modest one, ground source about 34,000, air source about 20,000. I added up all the houses and multifamily units and businesses in New York, and I got that we will need for New York State about 8 million heat pump installations to get rid of fossil fuels for heat and hot water. And I'll use the low end, the 20,000 per installation, multiply that times 8 million installations, we'll need $160 billion. That's $8,000 per person in New York State, or $24,000 per family. That's a real amount of money. That is going to take serious work. I don't think most of the families in New York State are ready to lay out 24,000, even if it's spread out over 20 years. It's asking a big ask for them. So the real equity question for me is who is going to pay for this and how? And all I've talked about is our heat and our hot water. All the same questions arise with how are we going to pay for making the grid clean? How are we going to pay for converting transportation? How are we going to pay for all of the weatherization and efficiency improvements we have to do to lower the heating bills in our buildings? So that's it from me. Thank you very much. I'm going to stop the share and turn it over to Emily. And I'm sorry if I ran over, folks.
Oh, no problem. And thank you for the presentation, Professor Leigh, and thanks for posing the question. We'll definitely come back to that. So yeah, I'd like to pass it over to Emily now. And Anna will start sharing the slides when she has them up. Thank you, Anna.
Great, thanks, Mike. Hi, everyone. Again, Emily Baumbach, Senior Sustainability Consultant with KC3. Also proud to be here as a new school EPSM alum. And just kind of before I dive into energy efficiency, I just want to give a really brief overview of Kinetic Communities Consulting. So KC3, we're an NYC-based minority and women-owned business enterprise that implements strategic energy equity market transformations for underrepresented communities in New York. So we work with energy industry partners and more specifically, affordable and supportive housing partners, really to connect, educate, and really streamline energy efficiency opportunities for these communities, and to help New Yorkers save money, feel safe, and really live in a cleaner and more comfortable environment. Next slide. Thanks. So I just want to give a quick overview of energy efficiency. We can think of energy efficiency as using less energy in order to perform the same tasks, such as turning on a light in a room or heating your home. And right now, nearly 70% of greenhouse gas emissions come from buildings, and 90% of NYC buildings that are here today will still be here in 2050. So energy efficiency is, it's good for New Yorkers and our city because it can really help to reduce greenhouse gas emissions, improves air quality, and can help make living and working in the city a little bit more comfortable and affordable. Next slide, please. Yeah, so how can we do this? I'm going to just quickly review some strategies that can include envelope weatherization, insulation, and then I'll get into a brief overview of commissioning of existing systems, and then go over some household efficiency strategies as well. So when we're referring to the building envelope, we're talking about everything that separates the conditioned space inside the building from the outside. So this can include the roof, walls, windows, doors, foundation, and having a high performance energy efficient envelope can significantly reduce your home heating and cooling costs. One of the most common ways that a building can lose energy is through heat transfer, but good designs can help to solve this problem. So heat can travel through a building envelope in 3 different ways. We have convection, so heat carried by a moving fluid, such as airflow, conduction, heat traveling through a material, as well as radiation, like sunshine coming through. And so if we can control these transfers, we can get huge energy savings. Next slide, please. So some of the effective designs for reducing heat transfer, this can include air sealing walls, fixing air leaks, sealing of cracks and holes, weather stripping doors and windows to keep cool air inside while you're allowing the inside temperature to stay cooler longer in extreme heat, and vice versa. Roof and wall insulation is also really important because it takes a lot of energy to heat and cool your home during the winter and summer months. So, if your home isn't properly insulated, your appliances are going to be working much, much harder than they need to be. So here on the left, there's a diagram of how after installing insulation during high temperatures, you can see that the temperature of the home remains cooler and isn't overworking that cooling system. And this is also important too, because, elderly people, young children, those that are in more vulnerable populations are more likely to become victims of, extreme heat and high humidity. So, it's important to make sure that buildings are properly insulated for that as well. And energy saving or energy efficient window treatments, those can also reduce your heating and cooling costs. And it's important to, work with a professional when you're installing those. Next slide, please. So these are just some examples of thermal imaging that shows the temperature of each surface for properties that were built to passive house standards, which is a rigorous high performance building standard that dramatically reduces energy needs of a building. So these top 2 images, the first one on the left, this is before envelope upgrades, and then the image on the right is after envelope upgrades. And then this second image below is a brownstone building that's meeting passive house standards, and you can see compared to the other buildings surrounding it, where those yellows and reds, that's showing the heat loss coming from the homes as compared to that passive house building right in the middle there. Next slide, please. So moving on to commissioning. So, what is commissioning? In existing buildings, this is, the process for planning, analyzing, optimizing, and verifying that the performance of building systems. So buildings that are properly commissioned, typically tend to be more energy efficient. They have lower operation and maintenance costs. And so building owners and managers want their buildings to operate at peak efficiency, but over time, wear and tear, equipment modification, and misoperation, these things can all really degrade the efficiency and performance of building systems over time. And so commissioning of a building, especially of an older building, you can really start to help uncover problems like equipment that's being operated when it doesn't need to be, simultaneously heating and cooling in the same space, improperly installed or disconnected or damaged ductwork, controls, valves, sensors that aren't calibrated properly, or even equipment setup that's been improperly adjusted. Next slide, please. So commissioning can help get a building back on track for optimum building system performance. And so some of the benefits of commissioning can include improved indoor air quality, extending equipment life cycles, documenting system operations, identifying and providing operations and maintenance training, improving performance by saving energy and reducing operational costs, identifying and resolving operation, control, and maintenance problems, as well as maximizing tenant comfort. And these are usually pretty low to no cost improvements that tend to also represent half of all the energy reduction measures in recommended saving packages. And so it's really important for buildings to not overlook these relatively inexpensive operational improvements. Next slide, please. So just moving on to household efficiencies, upgrading lighting to LEDs is a great way to cut down on energy costs. Richard did touch on this a bit already, but I just have an image of lamps starting from the left. We have, an incandescent bulb, then a CFL, and then an LED. And, so LEDs can save nearly 80% energy compared to incandescents and 45% energy compared to CFLs. And then there's even more savings on the maintenance too, since LEDs can last, upwards of 50,000 hours, whereas an incandescent might only last around 1,000 hours. Installing low flow faucets and aerators and shower heads, these are also really quick and easy upgrades for households and units. Showers generally account for somewhere between 35 to 40% of the total hot water use in a multifamily building. And so these low flow shower heads can really cut up to 30% of that water consumption. So, for the LED and aerator upgrades, these are usually pretty easy swaps. There are programs available for buildings to do this at low and no cost. There's actually a program right now where you can get air sealing, LEDs, and aerators. If you're an affordable housing property, you can get that all for free. So it's great. Next slide. Some more household efficiencies. This can include installing washers, dryers, dishwashers, refrigerators, which usually are typically the highest using appliance in a household. Even different types of electronics that are Energy Star certified. So Energy Star products, these are typically about 20% more efficient than their counterparts. So these can really help to save energy and money. And lastly, WaterSense labeled products such as water saving toilets. These are backed by independent third-party certifications that meet specifications for water efficiency and performance to help generate savings on your water bills. And I think that was my last slide. And with that, I'll turn it over to Jose.
Thank you, Emily. I forgot to mention EPSM, which is our great environmental policy and sustainability management program, which I am also alum of. And we're passing it over to our current new school student, Jose, who's also with Solar One. So thanks for that great presentation. I definitely have some questions about energy efficiency since I used to work in that field for quite a while. But yeah, Jose, feel free to start when you're ready.
Could you share the PDF version, Anna?
Give me 1 second. I'm about to.
Yep.
I just want to say that we're concentrating on building energy, and thank you, Richard, and thank you, Emily, for speaking so clearly and informatively about the issues of mechanical systems and heat pumps and energy envelopes. Now we're going to talk about renewable energy, which can be installed on a building, and then Jose is also going to talk about the larger distributed energy installations.
Awesome. All right. Thank you so much, everyone. It's a great honor to be here. I am José Gálvez Contreras, and I'm a senior program manager and solar researcher at Solar One. And I work as part of the Here Comes Solar program of the organization. I am also a PhD candidate at the New School for Public Engagement, studying public and urban policy, focusing on just transitions for energy democracy. Next slide. So what I'll be discussing with you today is I'm going to dive in a little bit about the importance of solar energy in New York City. Then I will introduce you to the model that we have developed at Here Comes Solar, and that has been a well-tested, sexy model that is getting more people and more buildings excited about solar energy, and also wanting to try and test this renewable energy technology, which is clean, easy, and affordable in many ways throughout New York. And then I will speak about 3 different ways that solar is developing throughout New York City, through rooftop solar on buildings, community shared solar, as well as resiliency solar, which is battery and storage. And then I'll open up for questions and answers. Next slide. So just to give you a brief introduction about solar energy technology. Over the last decades, the cost of solar has declined dramatically. So the cost used to be very expensive, and now it's very inexpensive. However, New Yorkers still face a lot of barriers in order to access renewable energy technology, in this case, solar energy. Those include construction red tape. There's a lot of bureaucracy that we have to navigate. So there's a lot of permitting through the Department of Buildings, the New York City Fire Department, and even the grid companies that we have to navigate. And not many people know how to go through those steps. There's also the system complexity for multifamily buildings. We live in a city that is dense, and that many people live in one building, and then there's only one roof. So we have to figure out how to make solar work in these types of environments. And as well, there is a dense urban environment. You know, not everybody gets to own their buildings. There's many decision makers at the table who would need to be convinced or to be brought up to speed about how to make renewable energy or solar energy technology work for their places. But solar is part of the solution of New York City's energy transition. First, solar can displace the fossil fuel economy. Solar here has a great future. New York City buildings emit most of the carbon emissions, so solar can help mitigate that part of what we're trying to achieve for a just transition. Additionally, as Professor Richard had highlighted, there is the Climate Mobilization Act, which is putting a carbon price on carbon emissions. And this is based on local law 97, as well as new construction buildings or major renovation on roof will require that solar energy technology or green roofs are being developed. So that's for local law 92 or local law 97. Solar energy benefits the old constrained grids. When we produce electricity right at home, it really helps and supports our grid, because now we don't have to bring the electricity from outside. We can just have clean, produce electricity here right on site. And additionally, when we think about solar energy technology, when buildings get to own their own renewable energy technology right on site, their bills automatically get reduced right off the bat. And of course, solar energy technology encourages new green jobs that can become available to all people, especially for people who are like me, people of color who want to insert in this new market, and we can develop this change in the city. Next slide. So Here Comes Solar is a program of Solar One, and this is an initiative that we're really focused in making solar energy become affordable and accessible to hard to serve markets. So what do? We provide free site evaluation and solar design technical assistance model, where we look at buildings as a whole and we see whether solar is able to be fit on that building's roof. We do knowledge buildings. We create basically these types of presentations. We go to meet with owners of buildings, building tenants. We meet with co-op board members, condo shareholders, you name it, property managers. We really bring information about how solar technology really works. We provide financing and incentive consultation. So we navigate all of the incentives that are available to New Yorkers and how they can make solar available for them at an affordable cost. And then we provide a solar installer selection assistance where we put requests for proposals on buildings' behalf, making it more competitive so we can get bids for buildings to be able to bring the cost down and that they can have a good solar installation on top of their roof. And all of the way through the process from beginning to end until the solar installation and past the solar installation being installed, we do consumer advocacy where we are really there for the client to really make sure that they are satisfied with their decision to having gone solar. Next slide. So the way that solar energy technology works, and this is the way that it would be on the rooftop solar, is that it's a very simple type of technology. Solar energy, in my opinion, is like the cleanest, easiest to maintain type of technology because you just have to install panels on top of a building's roof. And there are two main parts: the panels themselves, which are installed on the roof of a building or on a particular site, and then the inverter. So the panels absorb the electricity from the sun. Those panels send the electricity to the inverter, which converts the electricity from direct current to alternative current, and that goes back to the grid. In New York City, that's the best way to go solar, is by sending back the electricity to the grid, which we call as net metered. And in order to be able to fit solar panels on buildings' roofs, there are three types of designs that I kind of provided you 3 photos here so you can see. One is a ballasted installation. The ballasted installation is a very low profile type of installation. It doesn't require much. You just have to put the solar panels on the roof and they are held down with cinder blocks. And they basically, you can take the panels off if you need to do any maintenance on top of the roof. And this one tends to be cheaper, but works best when there is large roof spaces where you can put as many of these panels without the need to having to mechanically install the system. The second one is the planar array. And this one, basically, you would need to drill into the roof because you will have to anchor the system onto the roof itself. And this one, the panels tend to be closer to each other. So it's better for medium to smaller roofs. And if you want to maximize the solar potential. And finally, there is a canopy type of design where you can elevate the system 9 to 11 feet above the roof ground in order to use and utilize the roof underneath. So in case that some folks want to use the roof for recreation sites, or they want to use it, they want to keep it open because they want to walk underneath, then you can do a canopy system. So each of them are available to make solar be possible in New York. So we can get really creative on how to make that happen. But in case the buildings do not have accessible roofs, then we move to the next slide, which is community shared solar. Next slide, please. So as even though that solar is growing rapidly in New York, not everybody can have access to solar energy. And this is because there are still some barriers. So solar doesn't work for every single roof. As you know, we live in a dense environment. Some buildings tend to be shaded, or they don't have the roof space in order to be to have a solar panel on top of their roofs, as you can see on the photos on the left of my screen or the right on yours. Or you can have that many people who live in buildings do not own the buildings themselves, so they have no voice on how to make it happen, on how to install a solar system on top of that building's roof. So community shared solar is a great model that works, and that Solar One is also actively developing and helping to make it more possible for buildings, for New Yorkers. And this is the following way. You would find a site with a large roof space where you would install the solar energy system. The solar energy system will send the electricity back to the grid, and then then subscribers will sign up to that solar energy system and get credits for that. So they would pay at a discounted rate for that electricity, 10 to 15% less than what they would be paying to the grid for having signed up to community solar. And there are other alternatives where people can get together and install their own system and then own that energy on themselves. And that can become like true energy democracy in its own way. And the next slide. The other way that solar is being developed in the city is through resilient solar. So there are still some roadblocks to make resilient solar possible in New York City because of the dense environment. Again, it's very hard to install batteries all over the city, so it's very expensive technology. But nonetheless, it is not a model that does not work. Solar One has actually been working with the governor's office of Restore and Recovery in installing some beta sites where we are putting battery storage in order to have these places or these buildings serve as neighborhood resilience sites whenever there is like a disaster happening, such as we had in Hurricane Sandy. In the future, these buildings will have electricity because they have battery storage, but battery storage has not yet been able to be something that is being developed in New York City quite yet for buildings as a whole. Nonetheless, it is something that can happen in the future. When it comes to equity, what I do want to share is that even though solar, the prices have come down, that there's technical assistance programs like mine that are offering these services to New Yorkers at large, it is still very hard to serve underserved markets. And the reason is the way that the financial incentives have been working. So when we speak about equity, that is one particular point in how solar technology could be improved. It is by not giving the income tax credits that will serve mainly the well-to-do populations, but actually making a form of tax incentives that can help those people who want to have solar be able to pay for the solar system. So that's for my presentation, and I will open it up for questions.
Thank you, Jose. And I would just want to remind people that we have time. We'll have some time for questions. So please put your questions in the chat. And now we wanted to switch a little bit over to have a conversation between our panelists, which will, and most of the time, the rest of the time is going to be spent with conversation. But I had an original question, but I think I'm going to change it a little bit based on something Professor Leigh said, and a few of you touched on. But who, in terms of equity, like all of these things need to be paid for, and you all have talked about that. Who will pay for this, or who should pay for this? So I'd like to know, you can answer however you'd like, but yeah, that's my first question. So who will pay for this, or who should pay for this?
Oh, okay, I guess I should probably go first because I'm the one who said it's going to cost a lot of money. Who's going to pay for it? And I have to say, the answer to this is intrinsically not really technical. It's kind of political. But the fact is, as you can see, I am an older guy, and I've been around for quite a while. And I have gone to websites where people do serious economic research, and I've looked at the distribution of wealth and income in this country, both when I was a boy, which was quite a while ago, and what it is now. And over the last 50 years, there has been a mammoth transfer of wealth from ordinary people to the very rich. Everybody knows this. I mean, it's been the topic of a lot of conversations. But the fact is, it is a huge amount of money, and it is now sitting in the hands of people who clearly don't know quite what to do with it. They keep buying each other's stocks and buying from islands in the Caribbean to live on, or these days shooting themselves into space at $1 billion a pop. And that is money that we need. Now, I'm not recommending that we all go get guns. That's the right-wing version. But I do think that we need to organize politically along the lines emphasized by Bernie Sanders and Elizabeth Warren, and do some serious structural remaking of the way we manage money in this country. It's absolutely unhealthy to have a very small number of people holding on to enormous amounts of money, which they can then use to purchase politicians, who then do their bidding. There's only one reason that we've gotten nowhere with federal legislation to limit carbon emissions, and it's that the fossil fuel industry and their allies don't want it, and they've paid off enough senators and representatives to make sure nothing much happens. The most stunning example is Joe Manchin, who actually owns the coal plant that supplies the electricity that is supplied to his constituents in West Virginia at inflated prices so that he can get a lot of money for his coal that he sells to the utility. That was in the New York Times yesterday. It's great. Great story. Everyone should look it up. So I say need big structural change in the way income and even wealth are managed. We need much higher income taxes on upper incomes, and we need a wealth tax. Nobody needs over $100 million in their pension plan for their old age. They really don't. And having it the way we have it is doing ongoing damage to a fair fraction of the population of the country. So I made my speech, raw politics, I admit it, but that's what I think we have to do.
Divest. Those of us who don't have hundreds of millions of dollars at least could take what little money we have and make sure that it's not helping to fund the fossil fuel economy.
Absolutely. Yeah.
I
Oh, yeah.
I
There are
would
lots.
Oh, sorry.
Go ahead. I
Yeah,
talked
Jose, it
enough.
looks like you wanted to jump in.
No, I
talked
just
enough. Go ahead.
I just would like to add, just specifically in the solar industry, what I've seen is that there is a lot of debate on the types of incentives that are available to people. And the incentives, there is like a state incentive, but the way that that it is scheduled, it does help in the upfront cost for some to be able to pay for the system. But the later incentive, which is the federal and the state taxes, are mainly their income taxes, which only help those folks who owe a lot of taxes to the government and who want to have tax breaks, rather than people who are more on the lower end of the spectrum. It's very hard to make solar affordable for them because they don't get advantage of those taxes. So I believe that the way that the incentives are designed, they're not designed for the majority of the people at large. They're designed for a very few folks. And we need to break that. We need to break through that way that the taxes system is designed and help create tax incentives that are actually going to support the payment of these systems so that renewable energy can actually truly become affordable for all.
Great. Did anyone else have anything they wanted to add to that?
Yeah, I just wanted to kind of chime in since Jose was kind of talking about incentives, at least, from the energy efficiency perspective for the work that we do at KC3. I mean, for a lot of the properties that we work with, I mean, there'll be buildings that have a lot of work that they want to get done, they need to get done, but there's a lot of hesitation to get multiple energy conservation measures done, like in a single calendar or in a single application process, just because there's hesitation to kind of, jump into these utility programs, especially when there's these huge price tags that they're seeing attached to these. So because of this, we'll usually, we'll tackle maybe some of those lower hanging fruit measures first, like just lighting upgrades, air sealing, some of the more pretty straightforward, in unit work too. And then, then these buildings will be willing to apply for the deeper retrofits after they, feel more comfortable with the process. I mean, for the affordable and supportive housing properties that we work with, establishing trust that's really one of the most important things. And we want to make sure that they know how much they're going to have to spend and, what incentives are going to be able to cover the work that needs to get done. I mean, what we try to do our best is, find available incentive programs, find pilot programs that come up with the work specifically that they want to do with their buildings that have those really high cost shares specifically for the affordable housing buildings. That's one of the most important services that we can provide to these folks to help them with the work that they want to do. A lot of the affordable housing organizations that we work with, they have very limited funding. And, if they're tied up in the middle of refinancing, it's even more restrictive. So being able to let them know about pilot programs, limited funding opportunities that can even be greater cost shares than the standard programs, that's really what we highlight to them. So like there's a pilot program going on for electrification for domestic hot waters that we're trying to get a bunch of affordable properties to jump on, since the cost share can cover somewhere between like 70 to 80% of the heat pump installations.
Oh, yeah, sorry.
Just very quickly, from Richard's point of the sort of, global financial injustice and income inequality to the policy, if not corruption, then certainly undue influence of, fossil fuel and utility and other interests. I wholeheartedly agree. I think that from that point to Jose's point about the the disparity in the way that the tax system and the so-called tax incentives are apportioned also really doesn't equally allow access for energy efficiency improvements, retrofits, renewable energy to the vast majority of citizens and ratepayers. But I want to raise another point. What Richard pointed to as a kind of a what's the typical cost of an air source heat pump system to an average household, or a ground source, and you could extend that to any energy efficiency measure, an average in a house, single family house, multifamily building, a commercial space, whatever the case may be. One problem is that we look at this as a kind of retail problem, and we do not have, except for perhaps the community shared solar, which we need much more of, ways to aggregate these solutions in ways that achieve cost, economies of scale, streamlining of the process, greater uptake and adoption within the communities, all communities, but especially the communities of the disadvantaged communities and low and moderate income communities. And I think that's a great structural challenge. And why shouldn't a community not be able to get together and get some kind of bulk purchase of these solutions and be able to get access to the incentives in a way that isn't house by house and program by program. We work with these programs in our EcoSmart Brooklyn project, and it's very, very challenging. We talk about small and medium-sized multifamily buildings that are terribly underserved and ubiquitous across the city, use a tremendous amount of energy, and we just need to be able to deliver these solutions in a more comprehensive and a collective, collaborative way. And I think that that's something that we work on, that I know that all of you would support, and that we want to make this happen. And if there are any politicians listening, please, let's talk about it.
I want to add, because you mentioned community shared solar too, and it just spirals some thinking. Community shared solar is really great, and people are getting a discounted price on their bills. If you sign up for a community shared solar, you get anywhere between 10 to 20% if you're subscribed to a project, and that's great. But community shared solar, for the most part, is usually owned by large, well-to-do corporations or people who have the ability to build these systems. But what true, real energy democracy, or in thinking about equity, about making renewable energy, and when we think about electrifying buildings throughout New York, we have to also figure out how utilities are charging for the rate of kilowatt hour of electricity that is being distributed to every single home. Because it is very different for a low-income family to pay 21 cents per kilowatt hour than somebody that is at the very top end of the bracket to pay 21 cents per kilowatt hour, because the difference is that the person that is paying less, is that earns less, but it's paying the same amount as somebody that is earning more, can use that money for something else. So we need to figure out how the distribution of energy is being facilitated, but at the same time, how that energy cost is being shared by everybody.
Yeah, I agree with that. And part of my old job, one of the things I did, and I think this is everyone should learn how to do this, is learn how to read your electricity bill, learn what it means for supply versus like your distribution or transmission. Because I think a lot of people, if you're living in New York and are hearing this from New York, you've likely seen very high energy bills this winter. If you pay your energy bills, and the most of that cost is transmission if you look at it. So if you look at the actual amount of energy you're using, most people in an apartment or single family home are not using that much energy, maybe like 200 to 300 kilowatt hours a month, but your bill may be 2 or 3 times just because of the transmission. So I think starting with understanding, like you said, Jose, like understanding what you're paying is, I think, a real gateway to having like more energy independence and energy democracy. And speaking of that, I have another question I wanted to ask you all. So anyone feel free to jump in. How can these different solutions work together? Because you all have talked about, I mean, there is some overlap, but you all have talked about three fairly different, I wouldn't say efficiency as a technology, but if we want to say technology for argument's sake, let's say that. But how do we look at these three different things and how do we get them to work together? And not only for New York, in the New York context, but since we're all, I guess, experts in the New York context, I'd like to hear you all what your thoughts are on that, and anyone can jump in.
Okay, I'd like to jump in. And that is that I spent a lot of time about 15 years ago working as technical lead on a NYSERDA program doing about the work that Emily's doing now. And as a result, I learned quite a bit about the importance of all the things she brought out. And it's key to lowering the cost of putting in heat pumps. If people can do those energy improvement measures in a building, and they do count probably, well, they're different in whatever kind of building you're in. It's got its own particular set of improvement measures that are needed. Run-of-the-mill New York City apartment buildings masonry probably need new windows first to cut down on air leaks as well as to stop the loss. But whatever, doing all of that stuff will not only save you fuel as long as you're burning fuel and therefore money, it will make the cost of installing heat pumps less because you'll be able to put in a smaller system. And the cost of a system doesn't go to zero as the system gets tiny, but it does drop significantly and makes it much easier to fit all the parts in and hang the appropriate parts that are outside, and so on. So just doing energy efficiency first, and that was in one of my first charts, was I was showing energy efficiency up on top, and then I had clean the grid, and then down at the bottom, convert the fossil fuel. And I meant that, do all of those weatherization, energy efficiency steps first, and that will make converting the heating system and the hot water system that much easier and cheaper.
And let me second that by saying one of the challenges we face when we talk about electrify, and that's sort of perhaps the flavor of the month now in sustainability is electrify. Electric vehicles perhaps, or the flavor of the day, but whatever. We address the cost of that conversion, right? You say, oh, we want to stop burning fossil fuels in the house by removing that fossil fuel boiler, yes, but the cost of the conversion to electric heating and cooling is one thing. What about the cost of operation? Electricity is expensive. Gas at the moment is relatively cheap, but in order to reduce those operating costs, especially when we're talking about low moderate income users, it's the energy efficiency of the envelope. It's the efficiency of the building that's going to lower those operating costs. And even if the payback might not be the most attractive, yes, there are incentives, and there are incentives, smaller incentives for market rate properties. There has to be a way to look at this over the course of time and to make the investment that would really give us the climate benefits. The climate benefits are going to come from really lowering the energy use over time. And right now, the fact is that in New York City, the energy grid is dirty. Whether or not you think nuclear power is clean, I don't, but Indian Point is closed. And so now for the next 10 years or so, I believe, New York City is still going to be producing through its power plants. It'll be drawing energy from fossil fuel burning generators. So energy efficiency is not perhaps as attractive as solar or maybe heat pumps to some people, but it really pays off dividends, health and comfort dividends. And we have to find a way to finance that. And maybe some of those offshore funds can kick in some of that money for those longer term investments. And a lot of green jobs, by the way.
Yeah. Let me just toss a couple of things in. I agree 100%. Energy efficiency first, no question about that. But I do have a friend who has converted a 5-story HFDC residential building on the Upper West Side from one-pipe steam to heat pumps, air source heat pumps. Every apartment got their own individual heat pump system with the outside units hanging outside the windows. It's up on 105th, 106th Street. And the fuel bill for electricity from Con Ed to run it through last winter, not the winter that ended almost a year ago, was less than the oil bill for the preceding winter. It was not, there was nothing outrageous about paying electricity. And the reason is that the heat pumps are just much more efficient than a steam system. Steam systems, the oil is cheap, the gas is cheap, but the steam system loses a big fraction of it. But still, energy efficiency first. I'm not arguing about that at all. But I am saying don't be so terrified of paying the Con Ed bill instead of the electric bill instead of the gas bill. Oh, and Haym, it will be getting cleaner faster than you said, because NYSERDA has now got 5 gigawatts of wind, offshore wind, under contract. And that power is all coming into the city over the next 6-7 years. So it's not going to take 10 at all.
And more solar, lots more solar. Yep, thank you.
Any other thoughts from anyone about how these things can work together? I know Professor Leigh gave a really great explanation, but I wanted to see if anyone else had any other points they wanted to add to that.
Yeah, sure. Just a couple things to touch on quickly and kind of how all these solutions work together. I mean, one example is, our team, we might be coordinating, pretty closely with José's team at Solar One on a building. Buildings are really excited about solar, which is fantastic. We might be working with a building on various energy upgrades like heating and cooling, lighting, insulation, things like that. And then they express interest in adding solar. So, we loop in the solar experts like José and his team. I mean, I think something else that we already kind of touched on is the importance of, energy efficient heating and cooling systems, but also, having the importance of that tight building envelope too. If you have an efficient heating system, but a leaky envelope, the system is going to be working on overdrive. So you really want to have an efficient heating as well as heating and cooling and a good building envelope. I mean, I think something else that a lot of us can relate to is, having your window open during the winter time because your building is too hot. I mean, I had to do that for a couple of my old apartments that I used to live in. I think open windows in New York City, that it's a huge source of infiltration. It's a huge issue, and because of the uncontrolled steam heat in many buildings, New Yorkers open their windows to keep from getting too hot in the wintertime. And, this comes back to the importance of not only tuning and balancing those systems, but also providing those local controls so that, the systems are performing to the correct and comfortable levels for their tenants. And just kind of trying to bring it all together in one kind of package, I would say too. I just want to mention that, the New York City Accelerator, this is a program that really offers free personal advisory services to buildings in New York City that can really help building owners to, improve energy efficiency, as well as provide guidance on local law compliance, finding ways to help buildings lower pollution and reduce carbon emissions. So a lot of the different energy conservation measures we talked about, that program can help buildings affordable as well as market rate buildings with those. So we can, work with the owners, the property managers, and assist them with, making decisions on implementing some of these ECMs that they're interested in, finding ways to lower those energy costs, increasing comfort with their residents, and just finding ways to improve overall environmental performance. And that program really will work with any privately owned NYC building that's over, I think, 5,000 square feet. And I'll drop a link in the chat to the accelerator as well.
I'll just toss in that Emily's 100% right about getting local control into your apartment with a steam heating system, which you can do with thermostatic radiator valves or a cute device. Emily, you might have experience with these called a radiator cozy, where you put a box over the radiator and it only lets heat out when you need it. And that means that the steam actually stays down in the boiler and most of it doesn't even come up to the radiator unless the cozy is letting air circulate through the radiator. So there are ways to make your apartment comfortable without opening the window. And it's a much better way to do it because heating New York City outside air is really not a cost-effective way to live.
Mike, do we have any questions from our audience? Anybody would like to send a question through the chat, or have we seen any?
See, I'm looking. I've been keeping an eye on it. I didn't see any, but I do have a last question that we can add that everyone can talk about. And this will be the last question. So we've touched a little bit on some other things, but I'd like to know what each of you think for our last thing. What is one more equitable solution, policy or technology that we did not talk about that you're interested in, or you think would be something to discuss a little bit? So yeah, I'd like to know what you all think about that.
Wow.
All right.
Why don't you ask a simple question? I don't have a snappy answer.
I'll suggest one, and it goes back to the idea of I guess of the 2030 district, which is to find ways to collaborate on a community or a district scale. So here's a simple idea. We've heard a lot about, or maybe most of us here in the panel, and maybe our wonky audience may have heard of microgrids. Most campuses have microgrids. Some hospitals and big facilities, complexes have microgrids where they can share energy within a group of buildings, and island, which is a term meaning you can actually cut off from the grid if there's a power outage. You have energy that you can make on site, through solar or combined heat and power, on-site generation. You could have an independent power system. I think we really need some serious pilot projects at a district or community scale that would allow us to make and use power within a block or a group of buildings working together. There's no reason a community can't work like a campus and have on-site power and batteries and energy efficiency that work internally. So something like a block scale microgrid. This is not a new idea, but say everybody on a block that only has property lines between them. They only have their backyards and the walls they share to separate them. You don't need to cross a street across a public way to connect up. Might be able to share electric power, might be able to share thermal energy, maybe have solar, ground source and air source heat pumps, batteries, thermal storage within a block. Maybe there are commercial properties that use power at a different time than the residential properties. So there's a balance of the use patterns. We need to be able to start to think in these terms rather than the kind of retail, everybody's connected to the grid and the grid controls everything, or the Public Service Commission and the city and state regulations deal with everybody as an individual tax lot. We need to have some collective and collaborative opportunities. And I think that's the next phase. We need to address this, or we're not going to get there. We have to have ways to make economies of scale, and also, as José is saying, energy democracy.
I would like to add that, you know, one of the things that needs to start happening, I believe, is like more public control, like local control of the energy generation. So one way to do this is, you know, incentivize more programs that allow for solar or energy efficiency programs to be accessible for affordable housing or affordable low to moderate income housing throughout the city. We need to come with a solid plan in terms of policy on how the incentives will be impacting and supporting people on the ground and making it possible for them to own those systems. So that's one, like local control of the electricity, of the electric producing resources. The other thing that I believe could be something that it's important to make solar and just any type of energy efficiency measures like to blossom in New York City is that we have to take beta sites. And I think that the best beta sites that could happen is affordable housing throughout the city, particularly NYCHA buildings or buildings that are owned by the city stock, and make these campuses thrive just in general. So how can we make the people inside those places to benefit first from renewable energy access and from energy efficiency measures, and that they can become inspired by that they have access to the jobs that are being created when we try to make the systems work in those places. So it is important that we start to think not as just buildings for their infrastructure, but also the people who live in those buildings, because the buildings are populated by folks that require, you know, some way of feeling that they are a part of this new green economy. So if we don't create those jobs, we don't create the opportunities for people to feel connected to those new projects being developed, it's going to be very hard to transform a city as a whole. And I think that the way that we can start is creating beta sites that include affordable housing building stocks, but particularly those buildings where it's a public housing owned by the city.
I agree. And I think there's probably a lot of money in some of the infrastructure funding that came from Washington. Unfortunately, because of Senator Manchin and his you know, if not only misguided and or you know, corrupt blockade of this really, I think a really what could have been and may still possibly be a really positive and potentially revolutionary legislation through the Build Back Better program. There's still a lot of money, I think, within the infrastructure bill that could be applied to exactly what Jose is talking about, beta sites that really demonstrate the highest performance, the highest level of interconnection of these technologies and solutions, and also, as you said, you know, really drive the engagement of a wider and a deeper commitment on the part of the population, and get communities to really pay attention to this job training, but also just individual homeowners doing best practices and demanding of their landlords, of their government officials, of their you know, partners in business, employers, everybody, to take this much more seriously, put this on a higher priority. And then who knows, maybe we can shake some money loose from those tax shelters that Richard's talking about.
You know, just to quickly kind of follow up on what Haym was mentioning, you know, not necessarily a policy, but, you know, just when talking about transformations in the energy sector and more importantly, equity, I mean, I think one of the most important concepts to really highlight is community engagement and successful partnership building in this field. You know, for local communities, the opportunity to be involved in the energy sector, I mean, that can really present opportunities to transform the way, you know, youth are learning about climate change and the impacts that has on their future, and in the wide variety of careers and opportunities to be able to live in a clean and healthy environment. I mean, this also gives communities who are really bearing the brunt of the effects of climate change to be more involved and have a conversation and be part of these solutions. I mean, one example that I want to just quickly touch on for New York City Housing Authority residents is there was a recent formation of a new resident work group called the NYCHA Network for Climate Action. And this work group had the purpose to really give residents the opportunity to provide NYCHA with input based on their firsthand experiences on the challenges being faced in those developments and provide insight on building a sustainable and resilient NYCHA community. And we need more groups like that in the city.
Yeah, that sounds great.
Couple of minutes. Did you want to add anything, Professor Leigh?
No, I think we've covered an awful lot of ground, and I think the thing that ties most of it together is that everybody thinks we need more democracy at a root level and stretching on up. I would jump up one level and say that I think we could be getting a lot more done if we actually had public power rather than a private corporation like Con Ed managing our electricity. But as far as I know, the only people I've heard talking about this at all is the Democratic Socialists of America, who I like, but I'm not at all active with, and I don't even know exactly what they're doing on the topic. I just know they've talked about it. And,
Well, there's the community choice aggregation is a model that a number of municipalities, I believe, in New York State have adopted. It's nominally legal on the books in New York State. Achieving it in New York City seems to be quite a climb. But I think things like a community shared solar as a model for a subscription based a kind of a mass purchase, a bulk purchase energy model. But I think now, as Jose has mentioned, and I think that we've all agree, we need to figure out a way to have communities and citizens and stakeholders drive the projects rather than merely be consumers or ratepayers to the project. And that's a longer problem. Maybe that's the big action item that we need to work on over a series of meetings and events.
So it looks like we're about right at time. So I do want to respect everyone's time here. So I wanted to thank the panel again for sharing your great insights. And I will share tomorrow, probably likely tomorrow, we'll share the information that was shared in the chat, like all the links and everything with the different actions you can do, different things you can look into. And speaking of democracy, I just want to share this quickly. At the Tishman Center, we are doing our Earth, it's really like an Earth Month thing, but we call it Earth Week here. So if you go to tishmancenter.org/Earth Week, where we will be talking about democracy, design and art. And these are just some of the events that we have coming up, but we're planning on adding a few more. So we're going to have some talks, we're going to have a lot of talks about music, environmental justice, of course, art, and then we're going to talk a little bit about the New York streetscape, and then have a talk that relates pretty much to this about the IPCC report, the one that just came out and the one that will likely be out soon. So yeah, I just wanted to thank everyone again for coming out. I wanted to ask if the speakers or panelists had any last word of wisdom to share, and then yeah, we can let you go after that.
No, thanks for what everybody else had to say. It was very interesting.
Yeah, thank you so much. Really enjoyed participating in this panel and having this conversation with everybody.
Thank you.
Yeah, thank you so much. There needs to be like a follow-up to this.
Really appreciate it. And thank you, Mike, for convening. And we hope to work with the new school and all your wonderful students and faculty and even your facilities people in the near future. Thank you.
Oh, thanks. And yeah, we'll send this video out to everyone, and everyone have a good night.
Have a great one.